Hello, it's Han from Jeonbuk National University, where we are all about developing programming skill for GPU. We are now focusing on Jetson Nano and Raspberry Pi 4 board. In a demo today, we are using Nsight Eclipse, which is contained in Jetpack 4.5, and introduce how to build and debug a simple CUDA program, vectorADD, contained in CUDA Toolkit software. Let's open NVIDIA Nsight Eclipse and type any name as a workspace. In my case, I type CUDA-workspace-007. Then click OK. Let's go to the Jetson Nano board and make directory named CUDA test0010 in a home directory of Jetson Nano. After that, we return to Nsight Eclipse. I already make a vectorADD, so we try again. At first, we quit the Nsight Eclipse and run Nsight Eclipse again. In this workspace launcher, we type CUDA-workspace-008. Then click OK. Now we create a new project. First, click File, New, CUDA C project, then type any project name. In my case, I type test, and here we click import CUDA sample. We are using CUDA Toolkit 10.2. Now click next. In this dialog box, we click here and we choose a simple. Then we select vectorADD. After that, we click next. Usually, some documents recommend Jetson Nano board is the architecture is Maxwell. So in the case, they recommend to choose 5.0 for PTX and GPU. So I check 5.0, then click next. In this case, we try to remote connection. So I click Menu G and add some connection. My IP address of Jetson Nano is 192.168.0.5. Username is WCHM. Then click Finish. Project path is, we click Browser. Then they wanna try to connect with Jetson Nano. So we type the password of Jetson Nano. Then we are connected to the Jetson Nano. For this project, I already developed some Cuda vectorADD. Now we go to the Jetson Nano and make some folder under the home directory. Make dir ham. Yes, ham. So maybe there is some folder name ham. Not over there. Try again. Cancel. Manage. Already done. Browse. Click browse. Maybe ham over there. Ham over there. I select this ham. And for toolkit, we click the manage. Then in this dialog, we click detect. Then they try to detect some toolkit. They find this toolkit, so we accept. And in some example, we should add another folder path for some library. But in this simple project, we don't need no other library. So we just enough. And we click this checkbox, then we click finish. And we select ARC64 as a CPU architecture, then click next. In this case, we wanna build the debug mode project. So we just click debug only, then finish. Then they make some project called test. Now we try to build the. So we click build project. %, finished. In this time, we wanna check. We go to the Jetson Nano board and check what is going on. So we go to directory ham and check. Then there is nothing there. So we click the project and we choose the synchronize and select set active and check the remote menu. After that, we choose again synchronize and sync active now. After that, return to Jetson and what is going on. When we check the directory name ham, there is folder name debug and the source, and they have in a debug folder. There is a test executable file over there. So build project is succeeded. So next we try to debug. So we choose debug as and choose remote to C++ application. And in this dialog, we choose debug remote executable and remote connection. Well, okay. or we click manage. They try this one. Okay. Remote executable name is home wsham ham debug test. We make this a ham directory. In a ham directory, this test executable file is already built. So, okay. Then we next. And this is the toolkit path. This is correct. So we click next. So launch configuration name, test on wsham, no problem. So finish. Then click yes. Then they wanna try to launch tests on remote Ethernet. And the screen now turn to the debug mode perspective. So we click yes. Then debug breaks occur at this line. Then we can debug. Debugging is not working well. After there's some debug, this is kernel function. This function is executed by parallelly by using CUDA core. So in here we make some breakpoint. Then we click resume. Then break and again resume again. Then in here CUDA function called vectorADD inside of CUDA function break happen. As you see, we wanna watch this information of debugging. So we click the CUDA and we watch 8 block of 196. Only 8 block is now working. We choose one block. And they have 256 thread in one block. And in this block they have warp 0. Warp 0 has 32 CUDA core. That means warp 0 has 32 CUDA core. Because CUDA core is a hardware CUDA core, so warp 0 is running parallelly. Another warp 1 has another 32 CUDA core, and this is also running parallelly. Warp 2 also they have 32 CUDA core. Warp 3 they have also CUDA core. So maybe block size is consists of 256 thread. Next block also has start with warp 9 because last they also have 256 thread. So 8 block also has 256 thread. So the total thread number is 8 multiplying 256. That means 2,000. Almost 2,000 thread is running. But actually the CUDA core number of Jetson Nano has Maxwell architecture. They have only 128 CUDA core. So only 128 hardware CUDA core is running parallelly. After finishing, they just switching the warp and another 128 thread running fastly. The physical thread number is 128, but virtual thread number is 8 times 256. That means 2000 virtual thread is running parallelly. You understand? In this case, what is the I information? I is when we learning, I is 1, I is 256. So when we click this one, going, what is I number I? 128, going. Number I, 512. When running, I is 2048. To running, I is 2816, something like that. So they learning parallelly. Total number of this example is 50,000. So debugging of CUDA program in a kernel function is working well. After kernel function execution, maybe they return to here. Now they are learning this part of program. This is kernel function. After finishing, they wanna return to this one. So we clear the breakpoint inside the kernel function and click resume. What is going on? Resume. Some problem happened. Let's try again. I don't know why. Try again. Next, finish it. Click over there. So we make breakpoint over there, and maybe over there. Okay? Then resume. Go over there, then resume. So after finishing kernel function, debug break over there. So every debugging is working well as you watch this screen. So this is the short demonstration how to debugging kernel function and main host function by using Nsight Eclipse. This debugging is working very well. I hope this information will help all of you. Bye. Next time. See you next time. Bye.